Hello, hello, hello. Ready to tackle Advent of Code Day 12. Get my VS Code ready. Get my VS Code ready. Locker running. And here we go. Gardener, farm. We got another 2D grid of universe to do stuff with. Garden plots. Okay. Okay, so there are garden plots. What are these? 5 regions, all containing O plots. The other 4 each containing a single X. Okay, yeah, so regions can be separated by boundaries. Okay, you can calculate price. What's the total price of the thing? Okay. Ooh. Okay, I'm worried about this one. First, let me handle these stupid little things. So why I'm worried about this is because my naive brain says, okay, great, let's count. I'll just do a bunch of counting to determine, what is it? The perimeter and the area. But I know part 2 is going to be more complicated, and it's going to be like, oh, hey, yeah, that naive counting thing. That don't work no more. So, a little worried about that, but gotta make it work before we make it right. So I guess what we need to do is kind of like a flood fill. I take a position, and I'm like, okay, let's flood fill to discover all of your other A's. Well, all the perimeter and area of an A, right? So an area is the number, so we got that. The perimeter is number of fades that do not touch the same region. Ooh, okay, so that's kind of a lot of looking. So I look at this A, and I'm counting 1 for your area, and then I'm counting 1, 2, 3 for your perimeter. Well, this one, let's do this one. I'm counting 1, 2 for your perimeter. I'm also counting 1 for your perimeter, too. That's a double count, right? Because when you're here, you're going to count 1 against my perimeter. So if anything, there'd be an optimization there. When I'm counting my perimeter, I'm also going to add 1 to your perimeter. But when you count your perimeter, you shouldn't double count that perimeter. That'd be someone else counting for you. But that might be micro-optimizing. Let's just go for it and see how inefficient part 2 is. You might get lucky. So const results equals this. So for let r 0, r less than world dot length, r plus plus, we're just going to go for it. The columns, make sure we handle the rectangular universes. And const car equals world r c. Then we need all our neighbors also for const nr and c of -1 0 1 0. Nope, I've done all the wrong symbols. 0 -1 0 1. Then we have, well, these aren't new rows, these are offsets, so RO CO, our const nr and c equals r plus row offset, column plus column offset. Turn num lock back on. Const neighbor equals world, new row, new column, if neighbor equals undefined. Continue. Make sure to handle those ones. Okay, so we have this, we have this. Also want to make sure if not car and results dot car, well, not dot car, but index car equals area 0 and then param 0. There we go. Results. Let me record this. String to area number. Spell the word number correctly. Param number. We like that. Okay, so once you find that, it is results car.area plus plus. Good. Now we have to count how many neighbors are not us. That will increase our perimeter. So if neighbor not equal car, area, no, results car dot param plus plus. Why do I keep dropping this S? We got it. Okay, so this should give us results. Yes, now I just do the math, which is, what's the mathy math? Price. Okay, so let total price equal 0. Come on. Or const well, R, and then what? Area param of object.entries results total price plus equal new math. So it's something times something, right? Multiply region by area. We got that. Okay, so area times perimeter. Let me make sure that math is right. I don't need to make sure. I can just look at it. A3 is not equal to true. Well, it would help if I had a number on this. Total price is this. Oh, so you're not giving me the... great. So you're not going to give me an example for this smaller one. The above map, blah, 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 blah. The first example, A is this. Total price for the first example is 140. We got you. The second example, 772. I'll take it. Well, I'll take it after I get it working. Okay, we're not even doing good on the 140 though, so let's look character area parameter. So, according to the math, region A is a price of 4 times 10. Well, I've messed that up. So 4 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I see what I'm supposed to do, but I'm not doing it because I'm ignoring the undefines, right? So it's just if it's not equal, including if it's not undefined. 410, 410, 410. Okay, we're doing it, but we're not doing it correctly for the X. 5 regions, a bunch of O's, and then that weird X. Okay. In the second example, O is 21 by 36. O, 21 by 36. X is 1 times 4. X is 4 times 16. Ooh, each of the smaller, well, 4 times 16 equals 4. So 756 plus 4 plus 4 plus 4. I'm gonna do some... because they're different X's. Ooh. Ooh, ooh, ooh. That kind of is a flood fill to discover which ones are which. It's getting a little more painful. Mathematically, I'm like, why can we not just do this? Because that's 7, 8, 9, 10, 11, 12. Right? So it's 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 4 times 16. Why is that not doing what I want it to do? So 12 by 36. 756. Plus 4 plus 4 plus 4 plus 4. My brain is not liking this. 1 times 4, 4 times 16. Oh, yeah, they do math. Okay, yeah, so I can't just do that by character. I have to do it by actual grouping. I'm trying to see if there's any way easier to do this. That's not flood fill to identify groups. Since I'll do that, I'll need to identify members of a group to figure out when I detect new things, which group members they are. To that point, okay, I think I'll go the flood fill. Flood fill to collect group members. Let me think of the badness of this. If I start from here and just, start filling all the things. Yeah, if I only look for the ones that I'm looking for, that will suffice. Okay, let's do this. It's going to be painful. Cost groups equals an array of groups. So let me define this. Record. It'll be. What do I want? I don't want a record. I want an actual object. So we have members, which is a string array. And we don't want a string array. We want a set of strings. We're going to get really inefficient with this. And then we have area, number, param, number. And this is an array of those, right? And then we're going to go through this and be like, hey, if you're not in any of them, we're also going to want the character. Our string. Okay, so yeah, this works okay enough for what it is. We just need to do different stuff, unfortunately. To the point where, like, this is good, unfortunately. It just doesn't. Come on. Line comment, goodbye. It doesn't do good enough. So once we find a thing, we find a character. Get constitute key equals r, well, r number, c number, return r plus c. Good enough. Okay, so we have the character, we have the key, we have to make a flood fill function. Fill, that'll eventually be doing some stuff. Let's see. First we have to identify the group. Find the group, then find if this character is already in a group. So again, this isn't being efficient. What's my input look like? How efficient do I need to be? Okay, I don't need to be that big thing, but be a little inefficient. We're 140 by 140. Okay, so cost existing group equals groups find g dot, let's find the easiest thing to compare on. G dot car equals car, and G dot members has key. So key equals to key, not to total, to key RC. There you go. Sure, both of those. So if you're already in an existing group, then not existing group, then congratulations, cost group equals members is set. You have to make sure you got your initial thing in there. Key, congratulations. Area 1 parameter will need calculating. You know what? No. Let's zero these out. We'll let the flood fill do this. And then we have a character there. Okay, awesome. So really, we want invert this. If this is existing, to continue. Otherwise, I'm going to do my life. Flood fill. I need the world. I need my current row. I need my current column. I need the group I'm filling in for. And yeah, that will do the trick. And I'll do this. So yeah, so world string r number c number group. We're treating like this. Okay. Whoa. What I miss? I missed the closing bit. There we go. We're good. Now I got rid of that closing bit. Okay. The thing is, this never gets ran on something that isn't valid, so the additions and all that stuff happens up here. So I do need all the neighborly lookups. And let's remove that line comment. There we go, but we get our neighbor. If the neighbor isn't the character, then our perimeter, our group perimeter goes up. So group.parem plus plus, not be group.car. There we go. Else, then we're going to trigger the flood fill, but first we're going to group.area plus plus. This is our first run. Else, how do we make sure we don't go back to places we haven't been? We do membership additions. So that will be group.members.add, and it'll be 2 key. Yep, I've already unoptimized this. That's okay. Yeah, the check has to go somewhere after the call, before the call. Before the call is more efficient. Let's do less calls. Okay. So yeah, we technically do double keying for every single thing, but that's okay. That's gonna be triple keying. Ah, geez, it's expensive. Neighbor key equals to key NR and C if what is it? What is it? Group dot members has in key continue else don't need it, but we're going to do it. Flood fill world NR and C group. Don't kill my computer. Okay, I think this works. And now we have a bunch of groups. No, we don't. Why not? You should have groups. Oh, because I have this initial group that has nothing in it. Yeah, let's get rid of that. Why not? We have calls on all the things. Why not? Let's go with the easy example. Why not? I mean, let's just look at things, I guess. D, right? You're looking at a lot of things. What's your group? Oh, you're not adding the group, the things, right? You make a new group, but you don't add it. Let's fix that. Group stop push group. There we go. We probably have what we're looking for. Hey, I said have what we're looking for. I like to look at it. Okay, we have all our groups. Stupid tab character. Did I? Oh, I did that. Okay. Now we have to go through the groups and basically do the exact same thing. So for cost of groups. Boop, boop, that's a number. Now we get to watch how inefficient my algorithm is when I go to part 2. Let's go to part 2. Instead of using the perimeter, you need to use the number of sides each region has. What I'm doing. What? Okay. Has 4 sides, as does the regions containing plots. C contains 8 sides. Oh. 1, 2, 3, 4. Oh, that's a different calculation. Is it really just counting sides? Is that my only difference? It's literally just counting sides. Okay, I think I can do that. I don't have that vision in my mind at the moment. I think I can figure that out. So solve 2. Let me get my examples in here. Insert this example. Total price of 80. Let's do this. So next one. 236. We got it. And give me another one. Another one. 368. We got this. And our real, oh, that's not 368. What? The large example from below. You mean from above? Wait, what large example from below? Is this a typo I found? I think I found a typo. I guess I'm just confused about what larger region it's talking about. But if this one fails and the rest succeed, I'll let my paranoia skip it. Okay, we have all these. What's the big number for this one? 1206. Okay. So, I'm going to think my thoughts, and then I'm going to try and figure out what the actual implementation is after a short break. Don't want number of sides. So it's basically, we have side detection is going to be a four-dimensional thing. We can detect that these are all the same side by saying, okay, what? Ah, jeez. Because what we're really doing is we're putting points on a polygon, right? Like if we can imagine that, if we were actually creating this, like each of these are points on a polygon from line to line to line. And what they're asking us to do, yeah, true, this is not working ASCII land. But that's not mono. Give, give, there we go. Okay, so these are all points on a line, and this one, the C, they said, where is it? This one has 8 sides. So 8. Now, if I were to count them up, it's here, 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 here. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So what we're basically talking about is how many lines. 5, 6, 7, 8. I realize I started that count half quiet. But how many lines it takes up to make the polygon that is the area. Now, what we are doing currently is we're detecting how many line segments there are. So we're counting these. But like these are counted separately when we draw like, X's there. So we're counting like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What we need to do is collapse things that belong to the same line. Like if a line segment is the same X, Y, Y, X they share, like we need to merge them, I think is the idea. So that would be the naive approach. Like instead of counting walls, be like, okay, we have a fence from here to here. Congratulations, we just counted that. Oh, look, we counted another fence from here to here. And then a post-processing step is given this collection of fences, combine those that are in an exact straight line, that have the same direction, so north, south, south, north, and share a point. It's my naive approach. I'll go forward. I didn't mean to undo all that. My next idea would be it's kind of derivative of the same thing, but like we're talking about polygons, or like we're talking about points or vertices. So when we are saying, hey, look, we have a fence here, we're creating a line, but we're also just creating two vertices, and we're saying these vertices point to each other. And the optimization here is kind of literally the same thing I said, just different words. We have two shared vertices. Yes, I think that initial thing is what I'm going to try and go for. Generating the line segments and then smushing them all together for the group. Don't know how exactly I'm going to do that. Probably going to do like sub-coordinates, halves or something. I will figure that out after this quick break. returned I have, and line segment counting I am about to go. So, let's do solve 2, flood fill with fences, a cool new function name. And here we go. I think what we just need to do is add the additional just collecting of them. Fences, and my point, this is going to be an array of tupled to's and froms, and yeah, we're going to do it the bad way before we optimize the data structure. This is going to be not row and column because they're not actually on the grid, right? Like looking at the real problem. In this white, we have C, then we have R, yeah, these are our actual values. But C, oh, that a little further down. Like, if we were putting a, like this, let's represent this top fence position. It's right here to right here, which has a range of row 0.5 or 0.5, column 1.5, where'd my, there you go, 2, row 0.5 or 0.5, column 2.5. See, like, these are technically subgrid positions. So, like, I don't even know if I want to call them a row and column, but I just did, so we're just going to do that. Number C, number. Do I want to include directionality in this? Would it be nice? I think it's just be more complicated than anything. So let's go for that. Okay. So we have our fence detection up here. You're not one of those, so we're going to make a fence around you. Now, depending, that could just be 4 different ways to do this. So if I am at, yeah, let me not do that. So my position is R1, C2, C2, fence north equals, and by north, I mean -1, 0. My column, so I can see the middle of this column is this. So it's 0.5 left, 0.5 right. Then here, I subtract 1. No, I subtract 0.5 because I'm going up. I'm determining the heuristic for this because there's a, I don't need to write a bunch of things. I can just determine it off of this. So it's this divide 2 plus my row, and then the other one, you go 0.5 in either direction. Ooh, okay, this is getting real complicated. Const fence might have to be an if else, because one stays the same and one moves. Okay, so let me do that logic. If in or RO equals 0, well, yeah, else CO equals 0. So if the row offset is 0, which I'm not going through, so we're actually going to do the column offset, then const FR equals new row. Well, no, it's actually current row minus 0.5. And then column offset is 0.5 in both directions. So const FCs equals C C is 2 minus 0.5, C plus 0.5. Right. It's a tough one that's to do without visualization, to be honest. What's the worst that could happen? Um, Group. Yes, there will be double fences, but it is what it is. Where do we have? I don't have it on the other type definition up there. Let's fix that. Probably don't have it on the initialization definition down here. No, I don't. Look out, fences. Push. Well, it's really two fences. R F R C F C 0 FCs. Then another one. Did I not make this an array? Oh, whoopsie daisy. Fire type's angry because I missed a symbol. Whoopsie daisy. Now we need the other one, which should be the opposite. I'm worried about negative, positive, because the row doesn't. Yeah, I've done some stuff here. Otherwise, no, the row's not 0.5. The row is in either direction. So R equals, well, RO equals -1. Then it's 0.5. Otherwise, it's R plus 0.5. Yeah, I'm doing that bad conditionalism, but it's fine. And if this is good, then the same will work for the others. But I'll just effectively invert everything here. So I'll call you FC, call you CO. Not wanting to rename the entire universe. CO, I'll do this on the C level. Should have validated this on the other, but I'm here now. So row is FR's 0, FC remains consistent. Very bold of me. I've done some stuff now. Let's see what I've done. Now let's pick the 0th group. You look good enough to look at. Okay, you have a lot of fences, so you're the A group. So let's see how many you should have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 6 fences. How could you do that? How many perimeters do you have? You have 10 perimeters and 6 fences. You literally should have at least 1 for 1. How has this happened? This is where you set your perimeter up. What'd you do? They're all also focused on a single thing, which looks weird. 1, 2, 3, 4, 5, 6. Yeah, it's not even matching up with area. I mean, hey, okay, this is good. I mean, it's not good, but it's straightforward. We can follow this. So if group.car equals A, let's look at this freaking group. How many times do you even come through here? 1, 2, 3. You only come here 3 times? You have 4 A's. What example am I running on? Yeah, I'm running on the right example. Let me look at that. Throw another trim on there to fix it. Yeah, there are 4 A's here. Oh, this is the neighbors I'm looking at, right? Neighbors that aren't A's. So this is how many times an A finds a non-A neighbor. 3 times. I mean, I want to look at the neighbor at this point. Undefined B and undefined. Feels like we're not running enough times. Let me add another conditional up here. Not for that. How many times do you just straight up run? Once? Nah, nah, nah. You're not doing your thing. This works above, so obviously it is, but I'm not following. Nope. Okay, I was about to be worried that I just wasn't viewing everything, but it's once. I mean, we go through our members and we gotta call it again. So, like, you call your neighbors. I mean, put it there. Yeah, so you do at least one call to your neighbors. And then you have another flood fill call, which. No! Recursion. Okay. I don't know why type 2, because it was technically type compliant. Okay, great. So we have a perimeter of 10 and we have 20. I think this is probably close to what we're looking for. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're doubling, so it's 20. This works. We do have duplicates in here for sure. So if anything, we want to key all these fences in to get rid of the duplication. And once we do that, we'll want to de-keyify it so that way we can do the elimination and consolidation of lines. So let's do that. So fences, congratulations, you just got changed. Boop. Yep. Oh, let me over, and then we can hope that I've done all these correctly. So for fence of new fences, group fences, add to key, fence R, fence C, good enough. Have to do the definition down here. New set. We're good. Types are angry because things are not happy. Oh, there you go. Okay, so now we have a bunch of set. We have all the fences. And boom, we got rid of them, so that's good. So now we have 10, which 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Exactly. Now we have to start eliminating this, the extra ones, and this is going to be the fun part. Well, I don't really know how I'm going to do this. This could be, so it's just looking at it. They're not in order, though, are they? I mean, like, the ordering is arbitrary, is what I mean. It's like if I get this one, I'll need to get all the ones that are connected to it. Okay, so if I start here and then I find the ones that are next, then I find the ones that are next, and then if those two were in the same slope line or whatever, math, they can be squashed together. Or can I just do permutations of size 3 and be like, yeah, sometimes I'm going to get a weird permutation that looks like this one, this one, and this one. That's obviously not. I need to make edges between these and then follow the edges until there's a change in one of the other coordinates. So I need a freaking graph. So I have a disparate set of points, polygons. But how do I know that this doesn't edge to this? Oh no, I don't think I've collected enough information. This is bad. Okay, so I can handle these lookups by considering an edge and determining if the things on both sides are the same. If they are, it's not an edge. Okay, I think that works. I look at two things. If things on the sides are different, not an edge. This is getting kind of dicey, but it's what I can think of. So for cost group of groups, and now we need to make. So let's get the fences. Fences equals group dot fences. What have I done wrong? What's wrong here? Oh, wrong symbols. That's what's wrong. Fences equals group dot fences. And we'll need to map these. Boom, we have that. So now we need to try and make an edge between every single fence, doing the edge logic to be like, can you make an edge? Yes or no? And then actually making it. So cost edges, I guess is this. So for cost A of fences, or cost B of fences, if A equals B, continue. Otherwise, we're going to try and make an edge. And then I'm going to put a break here, or a return rather, so we can look at stuff. Great, we can't JSON parse these anymore. Why not? Oh, because they're not JSON parse. They are... like that. Eh. There we go, good enough. So now we have this. So it's 0.5, 0.5. So the column changes. So this is a vertical fence. I think this is this fence right here, right? So one thing will change, one thing won't change. So if A dot R equals A dot or B dot R, else it's the other one. So if the row is the same, vertical fence, cost left, cost R equals, okay, I have to kind of map this out. So if the row is negative 0.5, so we have 0, 0 here. No, we have 0, 0 here. Negative 0.5 is here. Column is negative 0.5, and this is 0.5. That should be enough information for me to derive things back out. Yeah, so I'll be able to figure out left and right. Or actually, I won't be able to figure out which is left and which is right. I'll just be able to figure out which the sides are, because I don't know if I'm originating from here or originating from a non-existent character here. That doesn't matter. So cost left equals R plus, well, minus 0.5, which is A dot R, and then column, well, hold on, rows minus 0.5, rows minus 0.5, column, hold on, no, row is consistently here and here. Column is changing between negative 0.5 and 0.5. I had the wrong line. So this is the vertical fence. So this one is horizontal fence. Get rid of that. Top will be, well, it'll be the least of the two. well, if it's 0.5 and 0.5, the row is actually up there, but which column is this on? It's on the one in the middle of it. So can I just say plus divide 2? Um, A dot C plus B dot C divide 2? No. I thought that would give me 0, honestly. Oh, do I have to do operations? There you go. Okay, there we go. So now if we do that for there, then we do cos bottom, which I think is identical minus the direction of the row. Alright, so the bottom is there, the top is there. If they're the same character, then we can edge them. If not, we can't. Okay, so if world top R, top C, not equal, world bottom R, bottom C, then they are not edgeable. So I want the truth actually. So if they're the same, then they are edgeable, and we can say edges dot push, and the edges are from A to B. Um, okay, maybe I don't want an edges like this. Maybe I want an edges in an actual graph. There we go. I'm trying to think of the right algorithm or the right data structure to do this because I want to do the eventual eliminations. So what I'm developing now is, let me just move this, kill this, move this back, kill those. Effectively, I have the dots, right? And now I'm developing edges between them. I need to find these groups of edges. Okay, so since it is always something that can be followed, hold on. No, no, no. No, no, no. There's an example of an inner edge. Where'd the X's go? Here we go, yep. So this doesn't throw a wrench in my spanner, but I have to account for it. These are 4 fences. They are going to be coordinated up. So I'll generate a bunch of things for, like like they'll exist. They won't edge to these ones. Or they better not. Alright. Ooh. Okay, I have to make sure this algorithm works then. So differences are good. Differences are good. Okay, yeah, that will work. They won't edge to each other like this. Okay, some things won't be in the graph, and that will be okay. So this isn't something the word for it like this. All points are not connected in the graph. There are multiple subgraphs. So as we do this, we're going to be pulling things out of our data structure. Then we'll be left over with some things, and those leftovers will have to be processed again and again until there are no leftovers. I haven't decided on that data structure yet, so that's an edge case. Let me figure out the base. We have this, we have a bunch of points. How would I want to do this the best way? My naive brain says start with a random point and for loop in a direction of directedness until we have 2 movements that are the same velocity, then go back, eliminate, regraph between these 2. So let's go with this example. We have this green dot here. Boop, 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 boop. These are all edged up. Now we go through these 2 and we're like, okay, this is great. We've made a new line. Let's add this to the new line places. Then we go to this next one and we're like, hey, we want the same velocity as the old line. Let's kill this line. Let's kill this point. Let's make a new line of double the length. That's my idea. And then, well, then you'll have this line with these 3 points. You'll go to the next one and be like, hey, the velocity did not change. Let's kill this line, this point, create a new line of just those 2 points. And yes, it's an efficient way of only doing that when you change velocity, but that's my idea. Trying to think of the data structure to support that though. I think in this graph, twos and froms will suffice. It'll just be double the work because I'll have to do froms and twos also because I have no directionality. So everyone will have 2 places you can go to. Right, that's the only possibility. Yeah, that's the only possibility. I'll make it an array of strings though, just to be good. So we'll say graph, and we'll just do const t key q key top row top column, and we'll do b key same thing but for bottom. Come on, get the word in there. And then we'll do directionality in both ways. But if not t key and graph, fix that, graph t key equals an array. Same thing for b key. Then we'll push to both, so we'll do it in this way. So graph t key dot push b key, same here but inverted. Now it's gonna be a lot. It's only half though. So I have the return up here. Let's put the return a little further so we can get at least some generations. Look at that. We have a graph of this one can go to these two. I don't like that. A single point is only supposed to be connectable to 2 other points. I don't like that. I don't like that at all. So this conditional is doing something. Okay, so I'm checking if they're both the same. They also need to equal the character. So if this and so if roll top key equals group dot car. Oh great, now nothing works. Wow, well no, it's not the top is equal. They don't need to all be the same. They just need to, yeah, if they're the same, I'm creating a point between them. Hey, I think that's the opposite. No. So wait, I think this is better. One of them needs to be the character. And group dot car. So something else includes parentheses. Let me get this going on here. It's a weird way of doing it, but we're doing it. Still loving this one, huh? Hey, what's up going up of here also? I'm using tops and bottoms. I should be using the what is it, A's and B's, right? So, I can just move these up because we're not connecting cells; we're connecting fences. Yes, the names are all wrong. Nobody cares. Okay, so this is at least more accurate. Still all the duplicated as heck. So -5, shouldn't be connected to 2.5. Ooh. Ah, boy, it's getting gnarly. Again, the fact that I am I feel like I really overcomplicated it, but I feel like it would work. Okay, maybe I just need to return a little quicker. So after the comparison, now let's look at the graph, see if I can follow. Yeah, so this one can go to this one, that one can go back to this one. Yeah, that one works. I'm gonna get the vertical fences in. I feel like completeness of it will help me see the bigger picture. And then I can start drawing a bit more. And maybe I can start doing some subspace or sub-coordinate pixel drawing, because that'll help me visualize it even better. So, const left, it's basically the same code here. That's a really weird way of doing it. We're just going to do that up there. Yoink. Yoink. Now, the difference is that we do this math on the left side. So, copy, boop, boop, keep the colon, might as well. This goes here, and this goes here, except the R's are C's, so let's fix that. These R's are there. It can't be that easy. I guess it do be that easy, though this never evaluates to true, so I don't think it's that easy. Let's look at A and B. Let's get the return going here. So we have different rows. Let me look at left and right, see what they came up with. Yeah, they did come up with a thing. Now they're not, it's not a good thing. So if we're looking at A, that is the graph. Assume we're looking at the A group. Yes. Okay, we found the first pair that is. Let me draw it on my map. So row is 0. So column is negative 0.5. So column negative 0.5. So something here. And row is 0.5 to negative 0.5. I think it's these two here. Negative 0.5 is here. 0.5 is here. Column is consistently negative 0.5. Okay, this is it. So that's what I'm looking at. And right is 0. Yep, left is negative 1. Okay, yeah, that's accurate. So yeah, you'd make a fence there. Why aren't you making a fence there? Oh, you are making a fence. Why is this saying a white dot? Like you never run the thing. I think maybe this conditional got really too complicated. Okay, so we did make a fence there. I'm gonna be enjoying this debugging later. I think I need to visualize this to really know if it's working. Okay, let me just start with an easy one. Negative 0.5, negative 0.5. That's here. So you're saying this should connect to row negative 0.5, column 0.5. I agree. You say it should also connect to row of 0.5, column of a negative 0.5. I agree. You also say it should be 0.5 to 0.5. I disagree. How did you go from there to there? Oh, I'm just connecting everything to everything. Yeah, that's illegal. What I need to do is filter you out to say, hey, if you absolutely differ more than 0.5, you suck. What I really need to say is you don't have a similar of this. So else if I see what's going on. This will help a little bit. This won't help at all. Won't help it fully. I not say at all. It won't help all of it. So we're doing this, but we're still connecting the ones that have the same but are like way further down. So this is if our difference on the one that's changing. So const diff equals if c diff not equal 1 continue, I think is what I'm saying. We need our diff here. The math isn't going to math out this way because it's I have to absolute this one, I guess. Oh, don't do that. How about now? Oh, now we just lost everything. No, 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 no. Put that back. Right. So I introduced two things. I got rid of them. I got rid of them. So hey, what is your C diff since you really love it that much? So there are some ones in here with 1. Okay, so I just need to look through the first example since that does actually help me. Let's put the return here. A, B, top, bottom. Right, let's look at what we got. Okay, I haven't declared y'all yet. Now look at them. Yeah, so this is this connection here. So what is my C diff? C diff is 0. Well, yeah, I've added them together. That's not a difference, idiot. Ugh. An idiot. Also, if it's not equal to 1, that's the ones you want to ignore. Let's see if that makes it a little better. We're gonna have that return right there. Let's get rid of it. Okay, now we've gotten down to 4. It's a very consistent 4. A single point should only be connecting to 2 other points, to be honest. Like, the only things you can connect to are these 2. There's not a lot else out there for you. So let's draw it out again. We're here, U. My brain, sorry. So negative 5 is good. So this one is connecting to negative row, positive column. So we went in that direction. Positive column, negative row. We went in that direction. Negative row, negative. Do we need to do sets? Ah, jeez. Can't handle a duplicate if my life needed me to. About now. Okay, now we've gotten rid of the duplicates. Oh, because for every A-B pairing, look at a B-A pairing. That's the least efficient thing I've heard in the universe. But let's get this working, and then we'll think of better ways. Okay, so I think what we do is the traversal is we take this and we go. We do need a single direction. So we go here to negative 5.05, negative 5.05. We need to not go where we've been before. So we need to have it visited. So which will tell us to go here, and then here will tell us to go here. Okay. Let's do this. So const visited equals new set. a new set of strings. So let path equals, I guess, our first keys of the keys. Well, this is kind of going to be a while loop, but while there's still stuff in the graph, right? We're building this path and we're eliminating things from the path. Yeah, so the path is our end result. So while true break, there we go. So cost path equals object dot keys graph 0, and let's say cost paths is right here. Yeah, so these are all the paths we've been on. We have our current path, which we're just gonna yoink something from the graph for, which means we'll be removing stuff eventually. So that'll be next equals graph path at -1. So I don't want next, I just want next. So dot find key equals not visited has key, so somewhere I haven't been before. And then I say path dot push next, and then I do next again. So it's basically while I can keep finding next. So it's another while loop. Ooh. So so we have our path, our initializer. We need that. Let's make this easier. Let's say const current equals here, right there, equals there. Let's do our next detection. If not next, break. We finally ran out of stuff. Otherwise, we push next. That'll do the thing. Right, there might be some non-existence there, at which point let's handle that. Shouldn't actually ever happen. And it's not a thing. So I just need to find one that isn't. So I need like union, subsect, all that stuff that I don't have, of course. So I think the sets were good initially. I don't think they need to be sets anymore. We're just going to do the inline conversion. Okay, now let's look at the path we created. That's not a path. It's not what I wanted. What am I doing? Oh, what did I find? I'm finding things, I'm pushing them. Why is he a bunch of, oh, they're a bunch of two-sized paths. Yeah, that's not what I wanted. Also have a break here. Okay, that's more like it. So we have a one link path. This is very sad. We should have been able to go to the next one. We're not adding to visited. Okay, I see our problem. So as we do this, we're like, hey, add our current to the visited or add next to visited. Yeah, visited, we'll push it here. Add next, which means this one swaps here so that way you can get path 0 in your initial state. Love it. Still not doing the thing. Okay, so I just need to log what's up. Current next. I'll have a break right here. Let's not do that. Oh, jeez. Okay, now it's starting to work. 1, 2, 3, 4, 5. These are all 10 points. Okay, this is it. Now, the trick would be after I get them, like I rip things out from the graph, so that way the graph doesn't have leftover stuff, and I can rerun the graph for each disjointed set of things in here. I think I'm going to do this right here, because this is where I access it. So once I get my next, I'll be like, delete graph current. It looks like this conditional isn't even needed, so let's drop it. We do need the array conversion. All right, and this ends up with an empty graph. That's right, except for that weird one case. So while object.keys graph.length. Boom, which means move the return down to here. Nice. I mean, we're not going to see it till we get to that one example, but it's alright. So I'm assuming this is a good path. Yeah, it stays 0.5 until we go down, and then we go back the other way. So this one will need to connect to this one. Purposes of elimination. So this is a circular path. Voila. But I think I have the data structure to throw at the algorithm of what I wanted to do with the whole elimination thing. And then I'll just have to do an extra hopscotch handling for the connecting the beginning to the end circular logic. Okay, I'm doing this all in one function. This is the best, cleanest code you've ever seen. So we have a path, we have a graph. We now want to just save our path because these paths are great. Paths, dot push, path. We love paths. Best paths. We now want to clean all these up. So for const path of paths. Now, the way I described it, it's probably the way I'm going to go about it. I'm going to start here and just be like, hey, let's go to the next one. Then go to the next one. And then, okay, so I guess what is my actual logic for this? So if I were to clean this up, I start somewhere, I go somewhere, I go to a third somewhere. As soon as I am at a length of 3, so I have a look back of 3 is what's going on. So I am somewhere, so I don't start at the 0, I don't start at the 1, I start at the third. So 0, 1, 2. And then I look back at the last 2. If they have the exact same row or column as me, so if we're all matching, then I want to get rid of the middle one. So that'll mean I will splice out that one, and I will move my index back 1 for array purposes. Yeah, I think I got that. For let s equals 2, s less than path dot length, s plus plus, and then, yeah, that hopscotching at the end. I'm not looking forward to that. Const last equals path s minus 1. Const 2 last with path minus 2. Const parent equals path s. Yes, there are probably better ways to do this. I like this way. So I just need to check that they all have the same row or column. Now, I don't have any of that information because we're just a bunch of wandering strings. Is it time for us to upgrade from strings back to objects? I'm trying to think, do I need them as strings to do deduplication or set lookups? I don't think so. So I think when I do this push, I'm going to map, in PA, I'm going to map, and it's going to be, I think I've done this code elsewhere. I'm going to go steal it. Here's the code. I'm stealing the code. Why did I do this? Oh, I did that for iteration of that. So yeah, that was a good thing. Literally stealing this code. Who's gonna stop me? Nobody. Boom. So now we have paths. Now these paths are objects. We love it. So I can just check if all 3 are the same with a very efficient if last dot r equals last dot r and last dot r equals current dot r. I guess. So it was very efficient. Then we're almost all in the same row. We got to get rid of last. So that will be path dot splice s minus 1 1, but then we got to go back because that's the way it goes. If, and then I want my other conditional for all the columns. Boop, boop, boop. Same behavior though. I don't have any in this A. I was about to be like, it ain't working. We don't do that in this A. Boom. No, oh, I'm not modifying. Well, actually, do I need to modify? I don't. Okay, so this works. Now, the one concern is that whole the cycle at the beginning thing. So I need to find an example where I would need to eliminate it. Oh, here's an example. So give me all of these. I said give me all those. So this is what I'm talking about. We did it. We eliminated all these. So we squashed this into a single line. This is a single line. This is a single line. Look at all these things. We did the greatness. And then we got to here. No, 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 no. We got to here. Because remember, these are disjointed points. And we're like, we're good. We need to like go one more and like do the elimination there. So this could just be as simple as adding the beginning to the end. Pass dot push path 0. It sounds lazy and bad. Cannot read properties on. Do I have an empty path? What the heck are you saying here? Oh, not paths. Path. There we go. And then I think I get rid of it if it equals the beginning. You know, weird hopscotch logic for this ending piece. But I think we have enough to look at it. I just need to get to the C, honestly. So where's the C party? Um, if group dot con equals the C, just show me what you got here. Oh, I return early, right? We never see anything. Sure. Okay, so we got to the C. Let me not do my weird fix and make sure it's broken. So 2.5, 1.5. Yeah, so you see we have three 1.5s here. They should be squashed. And they're all point. Yeah, they should be squashed. Now, if I do the fancy fix, how many are supposed to be in here? 1, 2, 3, 4, 5, 6, 7, 8. And I have 7 points. Let me do this again. I need to know what a real one looks like. All symbols. All symbols. Oh no, not those symbols. So let's not do the weird fix. Heck was A looking like? Right? So we have 4 points. Right? Because we're not counting lines, we're counting points. So how many points should this be? 1, 2, 3, 4, 5, 6, 7, 8, 9. 8. So there should be 8 points. A did well. They got 8 points. C, you got 7 points. Interesting. So you did a row 0.5, So you did this line, and then you did a downward line, and then you did a rightward line, and then you did a. Hold on. 0.5, 0.5, 0.5, 1.5. You have 2.5. These two match. And then these two match. And then I don't see how these 2 points are connected. My brain hates this. So you're at row 1.5, column 3.5, and you went to row 3.5, column 2.5. Seems illegal. I'm going to look at your original path. Because if I messed up somewhere earlier, that makes sense why this looks like trash. Yeah, you get 10 points. Lots of connections. 3.5, 3.5, 3.5, 3.5. And then, yeah, so this appears valid. So if all three of them are the same, then I get rid of the middle one. Get rid of 2.5. I'm almost there. It's just looking at numbers and building the map in my head. Not the most efficient means here. So I get rid of 3. Let me actually look at the thing. There was 1, 2. There are only 2 things you need to get rid of. So that's concerning. Okay, I can look to see when the removals happened. No, no, not conditional on that. Just conditional on logging. S. Right, so it makes sense. You never got rid of anything. You got rid of it on the columns. So 5, 5, and 6. So 0, 1, 2, 3, 4, 5. Yep, that makes sense. You got rid of this one. Why'd you come back twice? It feels weird. Um, all right, so you had 1, 2, 3, all the same. And then you had, oh no, 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 no. Son of a. Okay, I had one missing. So I think this is actually going to work now. Hello? Okay, now we have the 5 and the 9. Now I think the A is completely trashed. But I think the trick here is once you add that duplicate, you then get rid of it at the end. Yes, I think the trick is that do path splice. What do you do? -1, 1? Yes, I think that's the cleanup procedure I don't have. And now let's see if these look good. We have 8 points. We have 4 points. I'm feeling pretty confident. So now that we have all these points, I'm trying to remember what the purpose of this was. Not because I'm so far deep in the sub problems. How many sides, right? So it's how many straight sides. So is this literally this divided by 2? Or wait. So I have 8 points. No, it's just that's the number of things. Yeah. Oh, I think this might be it. Okay, so we have path. We love path. Path is great. We've actually cleaned up the paths. We are great. We are amazing. So we have our area, we have our perimeter, and we have our paths. Do we have our paths? Is that what we add to our group? Um, what are they calling this? So we have fences, so we have group in there. What are these? Yeah, okay, I'm not gonna worry about names. Just gonna try to get this thing working. Let's add another thing to our groups. Fence lines. What are they calling this? Just give me a name I can steal. Side count a number. There we go. Then I'll start. Side, not a string decoder. Jeez. Not a string decoder. Side count 0. We're good. We're good. At the very end, we go through all the paths and we add them all up to our side count length. Cost path of paths. Group dot side count plus equal path dot length. And instead of perimeter, it's times side count. I don't actually know the math for this. Group craft is blah 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 blah. Why is this one special? 2 regions of B's and a single region of A's. Be careful when counting the fence around regions, like the one full of type A's. Each section has an inside and an outside, so the fence do not connect across the middle of the region where the B's touch diagonally. Did I properly calculate a fence rest? The fact that it's not working probably means no. But let's see what I did wrong. At least I have it working for the basics, right? I'm happy enough with that. So we deleted it saying we're not going to need to come back here. Then we did need to come back here. We're manipulating the graph. Now this should be what we want. I mean, I can not manipulate the graph, but then, sorry, that thing's gonna come back and be like, "Hey, we need to like do more stuff." So would I just or you with an empty? array. This assumes you're meant to terminate and you're just running into your end. Ah, that's concerning. So yeah, there's a lot of steps here. I don't know which one's doing the problem, unfortunately. Look at our paths. Can't physically look at them, of course, because I don't have that. Well, we should have two groups, right? Can we at least agree on that? Okay, we have three groups. Oh, we have two B groups. Yeah, that makes sense. So let me see. The B groups have a side count of 4, right? And the A group has a side count of 14. Let me add them. Okay, Mr. 14, what do you got? So we got 1, 2, 3, 4. And let's go for the next ones. 5, 6, 7, 8, 9, 10, 11, 12. Uh-oh, I'm not seeing where you get the 14 from. So this is technically two fences, right? One on the inner and one on the outer. 4, and then 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's 12. Is the example say 12? Total of 12 sides. Okay, so we've narrowed it down to A's can't count good. Let me make this a little easier to follow for my life. And so 1, 2, 3. I promise I can count. 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I can count. Just in case anyone was wondering. So yeah, we need to look into these A's. They're being crazy. The fact that I had to do this, probably the concerning bit. Let's start with. There's a lot to start with. Let's just start with the fences, I guess. If the group is A. If group dot, well, R equals. I was about to say the first one's always A, but I'll put a return here and break everything up. So 39 points. I'm not about to count every single one of these. Square visualization would really start helping. And let's copy this conditional around. What do I assume is the problem? I mean, let's look at the end result, right? The paths will help us know. We should have one path. What am I looking at? Let me put this down here and do a trim. Make sure that's all good. Okay, that looks good. It's a lot of paths. So this is the outer, right? I can understand that. Ooh, here it is, here it is, here it is, right here, right here, right here's the problem. We start crossing over. So I bet what happens is our algorithm, give this back. Oh, give me some space, jeez. Is that we connect it to here, then technically this point has 4 connections. You can go in any direction you want, but you can't. Like there's 2 separate fences there. You can't actually go in any direction you want. This is supposed to look like this and this. They're not touching, but they are touching, which is why I needed to do the delete or the or, because like I come back to it and I'm like, I don't know where to go. This sucks. That's why they talk about the Mobius strip stuff. Ugh. Fences do not connect across the middle of the region. Okay, I see. I see what I've done here. Oh, that hurts. So I've actually implemented a more efficient fence to save them one thing, but no. We need to handle this. Huh. Yeah, my brain, it threw me through a loop. I was not anticipating. I wasn't anticipating whatever the problem was, but I am thinking on this one. So I could do some gross mathy adjustments, but like point one adjusting everything closer to its origin. That would make all the other math need to be adjusted, of course, but instead of placing in the middle, I place on the point fours in either direction. So that would like put me positive +4, negative -6. Yeah, and that would prevent overlap. I hate doing this, but I have enough test cases that I know if it will work in these other ones. It's a dangerous move, but I'm gonna do it. I'm trying to think, do I need to also do it up here? I do, right? Because it's positive, it's negative, right? Whew. Well, it's gonna be a big move. Let's do it. Okay, so if it's -1, then it's. Wouldn't it be point 0.4 in both directions? Let me look at this. And then the same one now, doing point 0.4s everywhere. Don't want to risk it. And then let's just look at group fences. Please show me the fences. So we're going to lose some deduplication here. I don't know. I'm just going with it, right? I mean, that's what we make copies for. We can always go back. We have the point 0.4s on there. That'll do that job. Top and bottoms, of course, these are all calculations are off. Oh, and then all do not start floating point at me. Oh, that's gross. Yeah, I just need to figure out which way it is to do the math properly. So this is math.round, I think, honestly. I hate it. I hate it. I don't think this is going to solve it though, because the whole point was I don't connect the edges that don't connect. When I round them, I'm going to squish them back to the same. Let's see what happens. I don't think it's going to work. It's the idea I got right now. Yes, I shouldn't need to do this. It's basically my test. It's exploded. Uh-huh. Yeah, let's put that back. Let's at least look at it post this, right? Maybe the graph looks right. Looks like absolute chaos. um, yeah, this is just for the first of the first. Like, things aren't connecting. Yeah. I can't change this to point 0.4 because I don't know which 4 direction it is, I don't think. I mean, I do have pairings in all directions, so maybe it would work. No. So, like, I think the AB pairing would work, but the BA pairing wouldn't work. So if I get rid of anything Doesn't have a length of 2. Would that do it for me? Because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points. Do I at least have those? So graph. I have fences. 16. Hmm. Alright, then you do 0.4, 0.06. Yeah, we lose deduplication. Ah, absolutely gross. So all of this is like, okay, I have a bunch of random polygons. I can then connect them up. I do all that. Them they're not random, right? They need more information attached to them during their creation, unfortunately. So let's go all the way back, drop all this point 0.4 nonsense. Yeah, okay, let's go forward a little bit. Still want to do a copy. There we go. Just don't want a point 0.4 at all. So yeah, I strip away too much meaning during the initialization. I think I need to keep the 2 in the front. So like I need to create the edges initially, not just the points. Because let me walk through this example. If I create all these with edges initially, let's assume we're going with the A's, then we're like, okay, I have an edge, this line right here. I'm going to draw them in a way that I can not touch. Then be like, okay, I have a line right here. They happen to touch. Then I have a line right here. Then I have a line right here. These are still 4 arbitrary lines. They're going to try and connect to each other. There's no distinguisher that this from to. Okay, I'm starting to see it. So they're arrows. Let's say they're arrows, right? From there to from there, but then you're coming back around from there, from there. Okay, this would still give me the situation of, okay, I need to go here. I need to find all the ones that are in this direction or in a direction that I haven't visited. So that would prevent me from going there. Okay, I think it works in a 2-dimensional space, which is what we're in, so lucky us. Don't like it. It's also going to require me to do a chunk of rewriting because right now I don't have directionality. So, like, that's not what these would look like. These would look like these, just 4 random lines. As I consume them, though, I'm marking them as visited, right? So, like, I did this one. It's like, boom, I visited you. I can go in any 3 of these now. I need to go to this one, not these 2. So I do need some distinguishing factor. And it can't just be from here to next, because that would put in consideration both of these. I'm trying to think during the initialization, like, because technically I wouldn't even make them in these order. These lines would probably get made in top left, the reverse order. Whew. This one is a stumper. Maybe I need to look at the problem more holistically, right? Like I have a polygon of points. They technically intersect. If I de-intersect them, that would work, but how would I detect that? Like, force them? I would be adding a duplicate, but then I would not scale. You know what? I might have to take a break on this one. I am that close, but that far. Yeah, I'm not saying it. So a break I will take. I have returned from my break and I have a seed of an idea. Instead of just having the points, we also need an origin point or directionality tied to it. What do I mean by this? Let's take our troublesome example and kind of look at it as if we have these two lines being made and these two lines being made. Now, well, these look horrible. Let's fix that. There, 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 and there. So we have all four lines. Now, this one has an origin of this A. So, like, let's just say it's facing this way. And this one, if I drew the rest of it, has also an origin of this A. It's facing this way. These two also have origins, both pointing coincidentally to this A. Not coincidence, it's how it works. Now, I think the rule about the pathfinding is once I add this additional data, it's going to be added to the points, but it'll be surfaced up to like the things, is that the origin point, like you can't do something that is more than a 90-degree turn, right? So again, origins are all this direction, origin this direction. You can go from here to here because you're doing a 90-degree turn. You can go from here to here because that's a 0-degree turn. You can go this way. You can go left because it's a 90-degree turn. You cannot go straight because that is a 180-degree turn. You cannot go right because, well, that is a 90-degree turn. But it's the wrong kind of 90-degree turn. Oh no. This idea is not surviving too long. Mm. Ooh, this is bad. Okay, so it's not just the turn, its directionality needs to be interior. So I'm trying to think of a situation in which you would be able to make a this turn in a real world. Because I could just start banning certain turns of like, oh yeah, you're going this way, you can only make left hand turns or straights. Or you're going this way, you can only make right hand turns or straights. It's like the rules of following a maze, right? So if we do that, then whichever way we're going determines how do I determine which way we're going? So like if we start here and we start at 0, -0, -5, whatever, we're going straight. Like how do we know if we're on the inside or we're on the outside? Okay, I'm just following this around. It's a bunch of rights. Okay, now boom. Let's say we start on the top left of this one, which is here. We take a right, we take a right, we take a left. The idea is there, but it's very raw, and I'm not seeing it fully fleshed out. It means I either need to think on it a little more, or I need to actually start implementing it and seeing where it leads. So one thing that is a precursor of all this is that I have points, and those points will have the origins technically. So it doesn't look like this. It looks more like this. Boop, 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 boop. And there are technically 2 points here. Boop, boop, boop. And then these all have an origin of like, where'd you come from? I came from here. This one came from here. This one came from here. This one came from here and here. Then this one came from here, here and here, here and here, here and here and here. It's a little tough to follow, but I'm gonna add another point there and there.
So every point has a certain number of origins. Right. So my fencing currently would squash these into singular points, which is not going to work. If I want to get this structure, we have to do something about that. So yeah, it's point and originating, which would result in three different points being here because they all have different origins. Hmm. Even if I did solve that, so like that's a challenge on its own, turning these into this. Well, I could go straight to these edges, but even if I did these edges, I'm not seeing the optimal way to stay on the inside. Let me follow this through. So we have edge, 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 edge. And they're really long, but pretend the rest of them are there. So let's say we start here, we have downward, we keep going, we take a right. We are allowed to do that. Then we take another right. We are allowed to do that, and another right. We are allowed to do that. And then we eventually go home. That's great. Let's look at this one. I guess we might as well just box it all back in again. Okay, so let's say we start up here. We take a right, a right, a left, a right, a left, right? So like there are lots of directions happening here. Originating there, originating there, originating there, originating there. Whoop, wrong arrow. Yep, so doing an interior and an exterior, they're a little different, but I need to handle them appropriately. So it's just every path after the first. That feels like it could really put us in danger. So the rule is it's a 90-degree turn. If I ignore directionality, then that's good, that's good. This would be good. Like going to here would be good because going from here to here, it's like, whoop, I can do that. That's a 90-degree turn. But you can't because that crosses over an existing edge. Is that the rule I need to create? Like, basically freaking collision? Ah. Right. Because the problem here is this is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm trying to remember why doesn't mine work? It goes too big, right? 4, 4, 8, 4, 4. What am I looking at? Ah, I'm not looking at the problematic one. I'm looking at all of them. Line comment. Okay, let's look at the problematic one again. 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then we do the 14 because we pathingly get confused in here. It's fine if we come up one path that's actually preferred. The problem is we make two different directions. So is this where we kind of split the universes, try both, and go with the one that is able to succeed? Is that what we're talking about here? Um, so what we need is potential paths, and then one go left, one go right. If you end early, you fail. Like I could see a way of trying that, basically like kind of building in the ability for it to fail, and then determining which one is right and choosing that one. That's gonna be the tough one. So that's what I'm going with. Going with potential paths. It's an array of paths. And then we're just going to path equals potential paths at -1. No, not at pop. There we go. And it is while path dot length. And yeah, our everything's gonna be broken. It's I. And then we all potential paths. We have the path. We do stuff with it. We need to finish it and push it somewhere. So my loops are kind of messed up. Sure, that's not where you pop that. So this is where the potentiality happens. Filter next. And yeah, we'll do that. If not next length break. Otherwise, for each, and then we do the delete. So for each, add new path. No, so we go through a path, and when we split, we add new potential paths, right? So we go through an entire path, then we split off as it finds new things. Gotcha. So const other next equals next. There we go. Then we're not gonna worry about. I guess we can do that there. Okay. Then after we have that, we can do the deletion. Yeah. So for const other of other next will be potential paths dot push. So it'll be current path and other. There we go. Okay, I'm liking this. A little lead in there. So computer probably hates me, but let's see. So what happens is now we have all these potential paths. We need to say const completed potential paths is where they need to go because we need to sort them out. And then if dot length equals 1, then great. Paths dot push. Potential path 0. Else chaos. Whoops. That's not supposed to be that crazy. Let's go to the one that isn't Mr. Problematic. Ooh. Huh. Which means there are other nexts? That shouldn't be possible. That shouldn't be possible. Did I goof stuff up here? That's hard to tell. I mean, I can go start control zing, but I don't want. Dang it. Okay, new copy, paste. Let's see what I left off with. I might have had some unknown changes that I hadn't tackled. Yeah, we have logging about fences. We have the conditionality, and we have the new math. Okay, so everything was good. Let's go back for it again. Now, let's figure out if we can just drop this and everything works. At least for the initial example. Okay, so this is good. So apparently, the entire time, there's this potentiometer thing going on. Maybe I don't understand how that worked initially. So there are other nexuses, which shouldn't be possible. Look, yeah. Oh, so there are two directions this entire thing could have went from the beginning. Okay, that's not a problem. Honestly, that's perfectly fine. They're equal, so we choose them either. That's perfectly good. That's because I do a undirected graph in both ways. I can clean that up by doing a directed graph. But I don't think that's a problem. I think we can handle that. So we do this, we have multiple paths. We have two. Ooh, that don't look right. Okay, I'm messing up pushing the additional path and other. Yeah, other is the place to go. Path is an array of things. Yeah, you want to do that. This is what you want to do. And you're only seeing it because this is, yeah. Hmm. Interesting. Okay, so it's not path zero, it's all the things in path. Um, fix that. Yeah, this isn't. I didn't really make this to be able to start with a more than one. Let's look at it again. Let's just look at that weird thing, I guess. It's just two. It should be able to continue from there. It shouldn't be failing. Hmm. Interesting. Let's chuck a return up here to prevent all the chaos. So, I mean, let's look at both of them. So, first one, we start at negative, negative. Yep, we start there. And then for this one, we go to negative, positive. But for this one, we go positive, negative. Yeah, that's completely valid. That's another way you can traverse through it. Yeah. And you have current. Oh, the deletes, right? Yeah. Only if there are none left, or yeah. So the cleanup is what's killing our second path. Yeah, array of 10, array of 10. Okay, if we don't do these cleanups, then we can't figure out which ones have been consumed. We only do the cleanups perhaps when we've chosen a path. Okay, I'm not opposed to that. We kind of need a problematic, or we need a way to decide which one's the good one now. It's the longest, it's the shortest. Like both of these look good on my eyeballs. Um, I guess if they're all equal, it doesn't matter. Well, if there's two, then it doesn't matter. So if the length is one is less than or equal to two, then it doesn't matter. It's when it gets higher. It's when a decision must be made, which means this is where we do our deletions, which means we delete the current of all of them. So for const, and what do we want to do? We're deleting what, keys, which, where do we get keys from? Oh, it's pre-map. Okay. RC of completed potential paths. Again, these are both identical. We need to delete for each key to key RC. So yeah, we have our cleanup. That's great. Let's go to number problematic now. That's an infinite looking loop. Return. Okay, finally. Whew. Word there. So we get 6 of them. Yikes. We have 8s and 12s. I know it's 8. Interesting, we got 6 of them. I guess that's how many variant options there are. I mean, we could just be like, boom, only consider ones of the same length. So that would bring us down to 12 and 8. Still 2, though. How do we decide the right one? You just be like, pick the lowest one, pick the highest one, right? 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. this case, it's the lowest one. Do we just go with that? Let's just see about that. Cost shortest equals math dot min. Well, let's do this a better way. Completed paths map. Then p dot length. Then math dot min. Shortest path length, and we just find the first one that's that, right? Equals completed path, find p dot length equals shortest potential path. Boy, my words are gone. And then we do this for that one. It's not going to work for like all of them, but it will suffice, and I'll do the deletions, which is really keeping this thing from working. Yeah, we're kind of just guessing. Shortest one. Not undefined, don't you worry. Yeah, let's drop some logs. A little easier on us. Yeah, unfortunately, it's the best I'm thinking of. Expensive, but functional. Okay, well, let's get rid of that while we're here. We have something. I don't even think Wallaby's gonna like it, to be honest. But let's get rid of our return and watch the chaos. Or get rid of our. Yeah, there is a return we have to get rid of. Burn. Wrong number. Huh? Wait, did. Oh, okay. This wasn't what I was expecting. A 10 and 8, 10 and 8. Okay, I want to see the one that's failing, actually. Line comment. 24, 8, 8, 8. Is that the end once we did all of them? 12, 12, 8, 12. Yeah, we picked the shortest one, which is an 8. Perfectly fine. Why am I seeing 24 and 3 8s? Hold on, 24 and 3 arrays of 8s. This looks really weird. 57 of them. We didn't have this problem before. Let's go back to this universe where it was just giving me wrong number. 24, 12. Why? Okay. To each path, we do stuff, we get rid of the duplicates, and we're good. Okay, let's look at the paths down here. Wait, what are these? We look at the groups, rather. We should see 3 of them. Yep. A and the 2 B's. Okay, that works. Let's do the fanciness. Ah, side count of 15. You've went up. How have I done this? So 7 arrays, a 24 and 8, a bunch of 2 3s, and then more 8s. What? Looking. 24, 12, a bunch of 2s and 8s. What are these? Yeah, 24, 12. What are these 2 long paths? Something is seriously broken. Path visited, potential path, you push all of them. Others, if there's no more to go, give up. And then take your completion and you're good. Okay, so it's gotta be in here. Police console log. Look at all these failures making it through. Okay, this had to have been due to my addition of potentialities. No, even scraps make it through without potentialities. Um, 2515, 2525. So that's a straight line. Confused. So the only thing I don't do is I don't do the deletions during it, which must have messed everything up. So let's look at the next from the current. And the path we're finding into is 25152525. Okay, it's going to take a moment for us to actually get to that one. Interesting. I've definitely over engineered this. Interesting. I can put the delete back. That's gonna break everything else, though. Does it get rid of our trash, though? And nope, we still get our trash. So that wasn't fixing it. And this does nothing because we have that rest commented out. So this has always been doing this craziness. 25152525. Let me look at that. So let's duplicate 25. So we have 0, 0, 2, 1, 2. So 2525. So literally here. What's the other one? Come on, where am I consoling it? There it is. 2515. So 25 the row, 15 the column. Okay, so this is weirdly a path on its own. 2505, 2515, 2505, and 2515. Okay. 3505, 4505. So 3505, 4505. Darn B. 3505. I already put that one. Then we just have this directionality inverted. Do I have duplicates sitting in here? I'm using sets. I should be. I shouldn't have duplicates. So 2525 can go in 4 directions. Yeah, that's our problematic one. 252525. Yeah, you're the problematic one. Show me the graph. Yeah, you can go up, down. Okay, no, that's right. Up, and then the two other directions. You are the only cause of it, though, right? So, but we're seeing potential paths way off there for some reason. It makes no sense. Okay, let's walk through it again. We have a path, we take the potential path, and we're like, okay, we visited all the places in this path. Until we fail, we go. So we take it and we go to the next place in that path. And then we just grab the ones that we haven't been to. We say no more looking at that. We go to next, other next. We ignore all the potentials. We just go for the first one in the set. We say we go there. We say we visited there. Seems straightforward. So when do we start at 2-5? Freaking okay. Let's start. Yeah, these beginning paths. They're the key. A lot of them. So 0505. That makes sense. 4505. 4505. So right here. Okay, that's an interesting place. The next start is 2515. 2515. It's here. And then 2505, 3505. Well, what about 0525? 0525. Right here. Okay, so I mean, yeah, obviously they're all around these freaking bees. When they join together, they're supposed to consume their old path. So let's look at the graph at this state, right? Like first one, get the entire graph at our feet. Second one, we should have a lot less of the graph. Yeah, 4505. That's the one we're going to tackle because it's the first one left over. Yeah, you're going to tackle that and you're going to consume a lot of other things as you do that. Yeah, you're going to consume 4515. 4515 is going to consume 4525, 4525, yep. Eventually you're going to get to, hold on, 4525. Take me to 3525, which does, and then that should take me to 2525. Then 2525 should take me to, not 2535, I've already been there. Any of these three, right? So it'll take us to 3525. Yeah, like I see what it's supposed to be doing. I agree that it's supposed to be doing it, but it's not because we run out of places to go at these points. So I mean, I guess I'll just look and be like, hey, okay, I might as well look at visited. Make sure those are being accurate. So yeah, 0, 1, 2. We're gonna get a length of 2 in there. And 2. You visited all the things you visited. So they basically match. So I guess we'll look at graph path at -1. Right, there's nothing left. That's why we're doing this. Hmm. Okay, so I can do a thing where I'm like, hey, let's ignore things that don't have their end touching their beginning and are a length of 2, right? So like I can do some cheeky stuff here. Half dot length equals 2. Continue if absolute distance between 0 and the 1th. Continue. Yeah, I can do stuff like that. I don't like it though. We even get an empty array here. That's scary. This is for the failed ones, right? So I guess we can say if not, no, if continue, right? Just move on for our life. We get these. We have errors of stuff happening. Okay, I think it's better. I don't think I've solved it, unfortunately. I do think I need these deletes. At some point, we'll put them here. It's a tough one. Definitely got my mind is spinning. Still not correct. So what groups do we got? We got A11 now. How did you get so low? So what paths do we got? We got 24, 12, 8, 8. These must get surely shrunken down. 4, 7, 4, 4. Okay, those two are the B's. These are both for the A. You went down to 7. Jeez. Let me look at that path. I'm looking at the beginning right here. Okay, that's great. So we got the 24. That's the big one. We love it. We got 12, 8, and 8. Right. So 12. Oh, I'm not picking the smallest no more. I'm just picking the 0th. Yeah, I don't want to do this. I do want to pick the smallest. Big thanks. Oh, so these aren't good anymore. 24, the 12, and the 8. Yeah, where'd yours? So I got rid of things that are length 2 and that don't have a length, and everything caught on fire? That don't make sense. Let's drop that line. Oh, I dropped the potentialities. That's why everything went on fire. Now, will I get my more potentials? I get a 6 and an 8. This is where I think I might need to do the deletion down where I have it here. Yeah, there we go. Now we're getting the rest of them. Okay. Now we're just picking the smallest one to be like, hey, get lucky. And now we're getting 13. So how many paths you got? You got 3 paths. No, you can't have 3 paths. You can only have 2 paths. So which the 2 paths you're getting? If group dot r equals a, trim that down a little bit. Oops. Okay, let's see what we got. So we got the 24 big one, right? And we got an 8 and an 8. So we got 2 of the 8s. One starting from the 2535, one starting from the 4505. 535, you do make it in a circle. 4505, so you do make it into a circle. You just decide to start at different places in the dumb thing. Why? Because I'm not cleaning up after myself, right? So after I traverse something, I should not be able to traverse that again. So right here, this is suggesting a full delete. Six. No. Yeah, let me see where we just got that 6 from. Let's go full charting. Let's get them up there actually. Home 2, 3, 4, 5. Nope. 5. Go. Okay, so we have our charting. Let's see what this path takes us on. Let's actually take it out here, make a Caesar myself. Great, so 4505, 4505, 4515. Wait, row is 45, column is 15. Oh, I just put it. Hold on, 05 is here. There we go. 15 is here. That's not an edge you can take. 4525. That should have been cleaned up. I'm looking at the post cleanup, the pre cleanup. Dang it. Um, Why you gotta be a little ugly? Okay, so a 3-point thing, which makes no sense in the world. Yeah, let's drop those. We do 4505. So you're there. Then 4525. You're there. 1525. Okay, I just realized 25's over here. But that's okay. And then, phew, we made a triangle. What the heck? Do we have improper edges? That's what that's telling. That's what that feels like. Like you shouldn't been able to do that. Like I saw your individual dots here. I guess there would have been individuals there. Feels like incorrect edges. You are the only one that does the craziness that I can see. Okay, let's look at the entire path. Yeah, bring this one back. Okay, so 4505 right there. Hold on, indexes are off. Dang it. Okay. Let's try this again. 4505, 4515, 4525, 3525, 2525. Arc Forbidden Corner. 1525. And that's it. That's your path. The path is illegal. So not only do we have paths, we have to make sure that their paths are actually good paths. So yeah, if length is to continue, if class diff, we just need to parse it out. Come on, mouse. Object path, boom. Object path, class first equals object path. Class last equals object path. Class diff equals math.abs. First, second row. What the heck? Our last row. And then what do we want to add these together? I want them to be different. R diff, class C diff. Yeah, still the same code, but for columns. And let's see what we got. All right, so we have ones of ones. This can't be true because we know we got this wacky one in here. What am I looking at now? Let's get rid of these ones. Yeah, we see more, but it shouldn't be possible. Okay, let's just console log them. So 0505, yep, that's a difference of 1, 4505, 4515. Where is this one? We'll go from 4505 to 1525. So they're all here. Where do you get that one? It's the one of length 6. So you're in the A's. You're coming from the A, people. I'm gonna look at the freaking path at this point. There you are. 4505, 1525. You're there. What am I looking? The it was I. Hey, look at all these great differences. Wow. Okay. So let's look through the pairs, see which ones are valid. This one's valid. You have a difference of 1. Invalid, invalid, valid. 0, 1, 2, 3. 0, 1, 2, 3. Okay, so if you have a R diff or a C diff of 1. So if you add them up together and you add a diff of 1, you're good. Okay. So if R diff plus C diff equals 1, then you are cool as a cucumber. You may move forward. Whew. Well, that was a lot of effort. Still not working. What do we got? A only has an 8. We got 2 4s. Well, you're supposed to have more than that. Got 2 4s. So you just literally make a big square over one of them and call it a day. So what paths do we have? 24, we got the 8, and we got the 2 other 8s. I'm not, okay, I am deleting early. If I don't delete early, I'll get more. They're all the 8s. I'm only deleting here when I'm cleaning. I need to delete at some point. 2 24s, 2 8s, a singular 8, 2 8s, 2 8s. A singular was weird. Okay, let's just look at the path. 24, we got the 2 8s, which I bet 25, 35. Yeah, I can see these are 3 points. Just it's this square or it's this square, right? That's all it's being made. So my other splitting should be resulting in more potential paths, which it is. So if we look at our initial path, yeah, we're seeing a lot, but we can see the split here into the 4 cardinal directions. But you don't make it. Why don't you make it? It's got to be this. So object path. Come on. Yeah, we got the good 24. We got the reverse 24. We got the 12. I don't want the shortest. I want the longest, don't I? Just realized that. I also just realized we're never actually getting that one through. Are they failing here? So 4505 circles back around to 1525. Hmm. Oops, didn't mean to do that. So 4505 circles back around. Oh, come back to 1525. 1525. You should come back to me. Okay, so I gotta follow this path through, unfortunately. Five oh five, 4515, 4525, 3525, 2525, 2535. We went this way. Cool. 2545. So yeah, we're going around this way. 1545, 0545, 0302, 1525. And then you don't go there because you've been there before. Ah, the visited. It's self or short terminating rather. So I do need to allow myself to go to places I've been before. This is you literally use only the one place to prevent you from going places you've been before. But that's really the only one to prevent you going backwards. But if we make it say, okay, just don't go backwards, you'll start cycling. If we remove places you can go, though, that'll work. Okay, so instead of deleting it fully, when we pick the one, so we have to allow it to go back to this position. That's the thing. You have to allow it to go back here only if you haven't been back home yet. But then that will allow it to go this way and be like, okay, great, we're just going to keep going because we're not home yet. So we need to allow it to go here, but not allow it to go there. It would be expensive, but it can also just be like, oh, you've been there twice? Nope, that'll prevent us from hitting that one. And that'll prevent more than 2 crossings from happening. Oof. What a stumper. There really need to be 2 different positions at that one. So the number of times you can visit it is the number of times it appears in the map. So if it appears once, you can visit it once. If it appears twice, you can visit it twice. Okay, now how do I restore the number of times something appears in the map? It's how many times it's linked to divided by 2. Okay, I can do that. So visit becomes a hash map basically, and then this graph for each one can visit times. So const can visit times equals new this for key and graph can visit times key equals graph key dot size. That's not a thing, my bad. So yeah, now this is a record of string to number, whatever. And now that'll have 1 for all of them, but except for that problematic, or 2 rather. I forgot the divide 2 bit. There we go. Now I use this. Instead of visit being a set, it's going to be a object for const. Ooh, we're not gonna have. Oh yeah, we can do this. So for const key and path, visited key equals visited key or 0 plus 1. Okay, again, have to type this one up. String number, then visited key. I think it needs to be less than can visit times key. And then we have to do this logic up here. Visited next is next plus 1. I like that. Allows you to double visit. Don't know if this condition is correct. If I visited 0 times, then this is technically 0. Well, this is technically 1. Yeah, visited. Oh, hey, that's not right. There we go. I think we need to go. Yeah, this could be off by 1, but let's see what we get. That looks like it's on fire. Bunch of twos. What the heck? Everything's broken. Cool, cool. We love brokenness. Wizard key. It's afterwards. This handle comparisons. Okay, finally we're getting stuff. This looks horrible. So you're going back to yourself. So now I need to put this back in place. Nope. Okay, 24. Good. 7, 13, 6, 12. Okay, so we're doing more visits, which is good, I guess. Ah, man. This is a tough one. Feels like I can do a little deep path trimming right in here, but we don't. We're getting there. So now I have a bunch of them. I don't know which ones are good. Oh, boy. Definitely feels like I way complicated this thing out than what it needed to be. 24 and 8, that's all you got. And 24 is all you get for the A's, so I don't even know where you get that second 8 from. Hmm. Let's see what potential paths we got. We should really see the split there. Yep, you start there, you go normal way, you go other way. You start there, you decide to go in the 4 different directions. Four, 5, 0, 5, 2, 5, 2, 5. You stop in the middle. So you went to 2, 5, 2, 5, and then you went to 2, 5, 3, 5, then you came back to 2, 5, 2, 5. You're an idiot, but that's okay. You went to 2, 5, 2, 5, and then you continued up, or down rather. Didn't you already come that way? Hmm. Because you get 2, 5, 2, 5, then you go to 2, 5, 3, 5. Hold on, 4, 5, 3 there. Then you maintain this till you make it to 2, 5, 2, 5, 2, 5, 3, 5. Yep, you loop, you loop. And then you're at, come on, where are you? 2, 5 on the column. And then you make it to here a second time. This is your second time. You should not have stopped. Do I need to say this? No. Okay, I need to look at my current, right? So eventually this will be 2525. Here we go. So if 2.5, 2.5. Great, so we're seeing that. What's our current path? Got a few of them. Let's see. At this point, we visited sometimes 2, sometimes 1. Right, so what next do we have? So that would be graph cut. Some of them completely have this deleted. Don't know how you got there. I'm looking at this one. So some of these might be the B's, I guess, right? Sure. Hmm. Hmm. I'm seeing a problem with that. Is this graph per group? Okay, okay. This is graph is per group, so we're on the A group. Group car equals A, and that should cut us in half. It does. So our first, second, and then our here's saying 2535. You haven't been there. That's cool. That path immediately dies. You keep going around. You run into us a second time. You should be allowed to continue on. So 012 my logs. 012 0. Oh, it's this delete, right? Okay, if I drop the delete, things change. Yes. Are they good enough? Lots of stuff. So I just need to delete from the thing that I visited too many times. Ah, so tough. I'm definitely gonna take a break off of this. I have gone in circles. Third time's the charm. I got it. And it got simpler, not more complex, thankfully. So I was thinking, I was looking, I was thinking, I was looking, and I realized I was doing the whole face edge detection thing, counting. It probably would have worked, but there's an easier way of doing it. Let me get rid of all these. I should just try counting the corners because that is how many like edges there are. So one. Okay, let's make that a better color than that. Like we got one here, one here, and one here. So that's those four. Then you got 5, 6, 7, 8, 9, 10, 11, and 12. That's it. That's all I need to do. I just need to go around counting corners. As for how to do this, I think it's all the way up in the initial area counting bit, where I'm just going to look for a pattern. I believe it can be like a 3x3 pattern or like at least a 2x2 pattern of the character I want is in both two cardinal directions, and a character I don't want is in the other two, or something to that degree. Something to that degree, but it's counting corners. I might need to be some weird stuff with inner, like these ones with like where it shares, but that is my plan. So let's do it. See where I want here. Corners is a number. We're gonna do the same thing somewhere down here. Corners is a number. Just gonna add that here. Corners 0, and now it begins. So I just need to detect that the character I want is in two cardinal directions and not in two other directions. I think. Yeah, I think that'll get me most of them. So for every area, great. I need to still do the flood fill of the whole other thing. So if it's not the thing, badness. If it is the thing, goodness. I've already checked you, continue. Otherwise, here we go. We detected the corner. So, I think the easiest way of doing this, because there's four kinds of corners I can detect. Like if I'm here, then it's that offset, that offset. Could also be, let's pretend this is the corner. If these two, these two, these two. So there's really four combinations of things I need to detect. So I think I'll just put those in. So it's basically both of them. If both of checking are the care and both of checking are not is corner. Which I think there's gotta be a better way of doing this. 2, 3, 4. Okay, let me think of maybe an optimized way, because when I'm here, I'm checking that the corner is in the negative directions. I can use that to derive the ones that it shouldn't be and the ones that it should be. So those are the four directions I'm checking for. The four const RO, well, CRO, CRC of, then the four corners, negatives. So that's top left, top right. So top right is -1, 1. Yep. Bottom right would be +1, 1. And bottom left would be +1, -1. So we do all those, and then let's say we're -1, -1. So we're looking in this direction. We want to get the left and the right. So const should not be car equals row plus CRO 0. Well, then the same, unchanging rather, right? So that plus -1 should not be, and this other one, so that's R, then C plus CRC, the one in the column direction, and then const should be R is the other two, which is R minus CRO C, so the opposite, I think. R C minus CRC. And if all of these are as their variable names state, then we are good. So if should not be car every, and then it's just R and C. RC world R conditionally, of course. C not equal car. Oh, what am I doing here? Group car, and well, not in there. And the other ones, all of them should be. So opposite, flip the variable, triple equality, and then kaboom. Nope, not color names. Group dot corners plus plus. Okay, let's see what happens about that. So we got groups. Before we do all that crazy processing, we might just be done. So let's see. This one has 6 corners. This one has 3. This one has 3. They clearly have 4, but they're not detecting them. And this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, they're not doing all of the counts. So yeah, let's look into that. It's curious of which ones are and aren't being counted. I guess I'll output R and C. Oh yeah, we're seeing everything from the universe. So let's Let's try it on the. These are the easier ones, actually. Great, nothing's working. Okay, at least we have less logs to look at. So, what is this one? I haven't looked at it in a while. Boop, there it is. Mono blast and white. Okay, so let's see if any of these are correct. So we have all our lovely. Oof, so much code. Our groups. So A has no corners, B has 3, C has 2. Right, so kind of chaos. Let's see what the easiest one to look at. It'd be the B's, honestly. So we're targeting the B's. If car, well, group car equals B, then let's just output the group, right? We should have 4 of these. 1, 2, 3. Huh. So what are we looking at? RC. So 102021. Are there only 3 B's? There are. Oh, there are 4 B's in here. Hey, what happened here? I should see some B's in here eventually. So I got 2 and I got 4. Where'd they all go? If there's an existing group with this thing, is that what's going on? Let's put a break here. Show me what's going on. Well, I mean, this will happen. These are all 4 cardinal directions: negative, 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 positive, right? We do this stuff, but that doesn't matter for here. If you've seen it, don't look at it again. Otherwise, you're looking at all the B's. Did I not? Is this input bad? There are clearly 4 B's in here. Apparently, we're also hitting other inputs. You should be. Don't know why we're looking at this. Oh, because it's passing on the first one. I didn't fix it yet. Okay, let's fix it where it's broken. Jeez. Okay, so this isn't doing its job. E's and X's. Let's figure this out. I need to look at it again. Well, the tab will break that. Okay, great. Don't even know why I did that. Thought they were broken. So great, they're fixed again. We love it. Okay, so the only broken one is the actual broken one. So are the A's off or the B's off? Six corners plus 3 plus 3. That would give me 12. Well, but I'm just off it. I'm not using the corners, am I? So none of them are passing. Yep. Okay, now that the tests are actually doing their job, let's look at it. So A has none, B has 3. Right, now that we have the world we're looking for, let's see if we hit the number of B's we're looking for. None of them are coming through twice, which is nice. So we have 102021, but not 22. Well, 0102. What about What happened to 1, 1? Interesting. I mean, it has to be ran earlier. Yeah, lots of runs on there. Yeah, mine is just not on game today. Okay, here we go. So, what we're looking for is 1, 0, 1, 1, 2, 0, 2, 1. 1, 0, 2, 0, 2, 1, but not 1, 1. Okay, so 1, 1 does hit here. Um, let's see if we bring this up. Do we see 1, 1? We don't. The only time we add to the members is right here. New row, new column, new row, new column. Ooh. It would help if I was actually using the right thing here. Right, this is my current position. These are all my neighbors. I don't think they should even be in here. Boy, this code's gonna look great when I refactor it. Alright, so as we do that, this is kind of just a first thing you do. There you go. I have no idea what's going on down there. Things are doing good now. 24, and I see errors here. So let's trim that fat really quick. There we go. Okay, a little better. Less running. 0 corners. 4, 2, D. Okay, well, is B working now? So B is working. What should C be? C should be 4. That's the thing. You look in that direction, you're like, oh, no, that's... Oof. Interesting, interesting, interesting. So that works for counting the corners that are there, right? Like, I believe counts 2. That corner and that corner. So these one-offs might need to get counted on their own. Okay, what about the A's? I need to... Nah. Oh, it's getting complicated. The D's and the E's. Huh. What if... What if I force there to be corners? What if I scaled everything up? As in... I've saw that trick done on grids for other stuff. 0, 1, 2, 3, 4, 5, 6, 7. And so we have 4 A's up here. And then the 1th line, you need an example copy office. Let me bring that back over. Is A. Now I have 4 corners. And now this is double B. But it's 4 lines of B's. All right, and then the next one is a square of C's. So like that, and then a square of D's. And then 2 squares of C's. And then We have 5 and we have 6. So that's a square of e's. So it's bigger, but it represents the same space, and my corner counting will actually work. All my numbers are wrong. Yeah, I'm gonna give that a shot. So basically, just double the world. Now when I do that, I just go over row every row and go over every column and just be like, hey, double. Interesting. Brain hates this. I could go through it inverse and just splice. Oh, and I can just do a map flat map. There we go. World, so it'll be a map. Technically, I want a flat map, and I just double this so it doesn't flatten all the way. Good. And then instead of 1L, it's this dot flat map C C, or C comma C rather. So that doubles it on that axis. Then you double on the vertical one, which is by me doubling this array. I gotta be dangerous. Well, I gotta be safe here because references and stuff. Turn this because I need this in multiple lines. Row, row, right? And then you return a row your boat. And that gives us a doubly sized world where my corner counting thing actually does its job. 4 corners, right? 4 corners on B. 6, 4, and 4. Does C actually have 6? 1, 2, 3, 4, 5, 6. It does. Okay, we might be onto a winner. No. No? Okay, I think I'm just doing bad here. What's um what am I supposed to be doing with these? What's the algorithm? Okay, the region contains 4, has 4. More complex C contains 8. I said 6. Contains 8 sides, huh? Okay, let me look at this. 1. Let's not draw in that color. 1, 2, 3, 4, 5, 6. What are we talking about? 8 sides. A contains 4. B, D, and E contains 8 sides. What is a side? Each straight section of fence counts as a side regardless of how long it is. I don't see it. 1, 2, 3, 4, 5, 6. Regardless, 7, 8. Dang it. Okay, this should still be counting my corners because 1, 2, 3, 4, 5, 6, 7, 8. I am failing by 2, which is exactly how many, what are these? Inverted corners there are. I'm not counting these kind of quarters, so I need an algorithm, or I need the code for that rather. Okay, I got that. We got that. Just need another thing. So, what determines a corner? Oh no, go forward. This thing doesn't have forward, so that's gone. Dang it. I don't have a clipboard either. Okay, I'll just do a quick one rendition because this has already been very long. So C C C C C C C C C C C C and then C C C C. Okay, this is what we're looking for. Let's figure it out again. So we're looking for all 4 cardinal directions being good, but the direction I'm looking at being bad. Well, technically, we're looking for the direction we're looking in. So let's say we're looking in this direction. We're looking for the ones along the cardinals to be good and it to be bad. Okay, I think I can do that. So that's for the one special kind of thing. So if world R plus CRO C plus CRC equals, or not equals, not equal group dot char. Let me add this to keep everything from firing off. All right, the other conditional, which is the two on the horizontal, should be characters. So it's actually should not be char, is char. So this is hilarious. These namings suck. Boop. Did that get me? No, I think if that works, that's great. It has to not work too many times, though. Okay, well, that tells me nothing. So A's got 4, B's got 4, C's got 8, D's got 4. Now what's wrong? I have the right numbers. Instead of using the perimeter, calculate the price, you need to use the number of sides. Okay. So total price of 80. A through E have prices of 16. I'm going to look at you now. Ah, freaking give me the character. So A is 60. No, it's not. Are they supposed to be plus? Is that what's going on? Did I just goof a symbol? No. A through E have prices of 16. So A has 4, and they have 4 things. 16. Are my area calculations trash? I have an area of 16. How did that happen? When did this happen? Am I calling it on things that should not be called? Um, RC group dot R. Yeah, so it's gonna be a lot easier on one line. There we go. Drop, drop, drop. See what we're looking at. So yeah, those 1, 2, 3, 4, 5, 6, 7, 8. Oh yeah, half my area. So plus equal 0.5. 0.25 actually, because oh jeez. Okay. No. I feel like I am doing something really obviously wrong. So because we doubled it, well, we quadrupled it rather. I thought we just quadrupled it. Yeah. So let's go back to 25 and let's go to the next calculations. Yeah. 4 times. I'm gonna look at these freaking corners now. Nope, not that. Yeah. 4 times 4 is 16. A through E have 16, 16, 32, 4, and 12 for a total price of 80. I swapped the symbol, but I didn't swap all the symbols. Okay, good, good, good. And computer go burr, I get number. Whew, that was a long one. But I made it. 99 ways not to invent the light bulb, folks. Ooh, so yeah, let's commit that atrocity and get to the walkthrough. Come on, show terminal, please. 12 in the books. There we go. Let's drop that old time travel bit. Before we tackle that mess, let us walk through what they actually wanted us to do. So, another 2D simulator. We're given a grid with individual labels that represent full on regions. So, these four labels all mark these four coordinates as region A, these four B, region B, all of those accordingly. Regions with the same letter can like be completely separated from each other like islands, and they count as separate regions. That's important. So we're supposed to calculate, for part one rather, the area and the perimeter, which is used to calculate the price and return the price of all areas. So all regions rather. So they make it relatively good on this drawing where they're like, hey, look, this is the like the separations of that where they just exploded the top one. And the area is literally how many squares you take up. So A has an area of 4 and a perimeter of 10. I'm trying to remember this logic. The sides that don't touch with the same region, right? So perimeter of 10. It's the actual definition of area and perimeter, thankfully. So it's relatively easy to follow along with. So, how many walls or fences you need to place up to separate it from the outside world, or how many ways it touches things that are not itself. They explain that there can be separated regions of the same letter, those are separate regions, all need to be processed accordingly. And then the actual processing, which is going through each region, getting its area, multiplying it by its perimeter, and that's the price. Add all those up, you get a final price. That was part one. Part two is just using the number of sides, not the number of edges touching other things. So that looked like for A, it's 4 sides because you have top, right, bottom, and left instead of 10, where it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's just 1, 2, 3, 4. You can imagine it like, hey, we're gonna like if we were gonna like rope it all off, then it's like, hey, how many segments of rope would you need, or how many lines make up this particular polygon? As for how you count that, well, you can do it in like half a dozen wrong ways. But once you do that, make sure it works. There are regions like this where they do not like share a single post in the middle. They're separate counts. So 1, 2, 3, 4 for the outer A. 1, 2, 3, 4 for this B. 1, 2, 3, 4 for that one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are not touching despite like the diagonalness of it. Yeah, that's what they wanted. How to do it? Boy, I went all over the world, but I will try to explain in the least amount of chaos as possible how this code works, and then we're going to do the great refactoring, and it will be great. So let's start with the first one, or solve one, because I was able to tackle that relatively straightforwardly. So first we need to turn our world into an array of arrays as classic. I'm also going to go turn that off down there because it's eating my CPU. No, not there. There we go. No more CPU eating alive. Okay, back to the walkthrough. So yeah, we break up our world into an array of arrays, and then I set up a array of groups of like, hey, we're gonna track who's part of your group, the area of your group, and the perimeter of your group, and the identifier of which group we're tracking, which is the character. In hindsight, this could have just been a hash map. In the refactoring, it will be a hash map, but we're not there. So then what we go through is, hold on. Yeah. So then we go through every row, every column. We grab the character. We're like, hey, are there any groups that you're already a part of? If so, we're not going to run the flood fill algorithm on you again, which is just looking through and finding all of its neighbors. Looking at this again, I didn't need to do flood fill at all. It just felt like a flood filly thing. And when I refactor it, I'm totally going to put it in here. But I don't need to flood fill since you just find the group and you make your changes to it. But that's what I chose to do. So if there's no group with you in it, that sucks. Otherwise, then no, I did need to flood fill because the same letter does not mean it's the same group. So this is important. Make sure that we don't reprocess groups we've already processed our members before. If not, it means we have a whole new world to explore. So we create it, initialize everything to 0. It has one member, call the flood fill, and we save the group. The flood fill, what it does is it does the initial stuff of like, hey, we found one more and we have another member. Let's not process them ever again. It then goes in all 4 of our cardinal directions. So if I were to take this one, then yeah, from A, it'd be like, okay, let's look in this direction, this direction, this direction, and this direction. 2 of these are going to fail out, so they don't go nowhere. The other 2 will, so the B will look at this and will be like, you're not one of those. You are not cool. You are not the character I'm looking for. So you must be part of the perimeter, right? So we're making perimeters. So we make 3 of them for all 3 of the failures. But for the success here, this A here, we're like, okay, you are one that I haven't seen before. Well, you're one of mine, so you belong to my group rather. But have I seen you before? If I have seen you before, then I don't want to process you again. But if I haven't, then you're the next one getting processed. So then it does it again. It looks in all 4 directions. It fails up, fails down, draws perimeters in both of them. It then tries to go to the left, generates the key for the left, but it sees it's already processed the one on the left. So it doesn't do that, but it also doesn't set up a new perimeter there. That's not that code. It then goes to this one, and then goes to this one, and then boom, it has processed all of them, added 1 for every single perimeter, and added 1 for every single A found. And yeah, this is classic. All 4 cardinal direction offsets, generate new number, get your neighbor. They might be on a row that is undefined, so be safe of optional chaining. That's it, yeah. And the final bit is going through each group, adding up the area times the perimeter, which is the way to calculate the price, and then returning the price of all of the groups. Anything looks straightforward compared to the mess I drew down here, or I wrote rather. Let's look at it a little bit. To be clear, I'm going to look at what worked, not all that chaos below. So let's put the return on this. Again, focusing on the same happy path. So, first thing we did is in order to count the number of faces, as they say, part of that is to count the number of corners. That's the geometrical trick, I guess, to this, is that for every corner that corresponds directly to the number of faces. So once I figured that out, I was like, okay, great. Turns out, in order to count certain corners, they're really small, but they're not as small if you literally double the scale. So that's what this does. It turns the original 4x4 array into an 8x8 array by mapping through each row and returning two rows, and flat map turning them back into like concatenated. Doing the same also for the individual cells. So it gets us a really big world. Then we do the exact same thing for our membership stuff. We have a lot of extras here. What matters is the number of corners. All of this code is exactly identical. Our price calculation is just multiplying by a different number. And our flood fill of fences is where the magic happens. So after we add a quarter to the area, because we're zoomed in at 4 scale, we check if it is a corner. Now that there are two kinds of corner, apparently. There are inside and outside corners, is my best description. So we have corners that there are two walls, so that's why it's a corner. It's like you're that's that kind of corner. I don't know a better way to say it. Then there's the corner that's the pokey one that you don't want to walk into. So both of these need to be detected and counted appropriately because they count for how many faces there are. So for the not pokey corners, the huggy corners, I guess, I was able to basically determine, okay, for whichever direction I'm looking, if I'm going top left, for example, let me find the top left example. I'll just use this one. If I'm looking top, let's use this one. If I'm looking top left, then these two must be me, and these two cannot be me. So there are two that should be me, and there are two that should not be me. And if I'm looking in this direction, that means I am -1, -1. So if I do -1, 0, that puts me in this direction. If I do 0, -1, puts me in that direction. So I can use which direction I'm looking at to find the to programmatically find basically like the horizontal, like basically flatten this arrow in either direction I want and just find that direction. And then I can invert it. So invert it and then flatten it to find the opposite too. It's a little bit gross math, but it's not too bad once you see it. So I do that. I do the weird flattening of like, hey, these are the ones I'm looking at. These are the ones behind me. And I named them like these, which were accurate until they weren't accurate. I made sure that for every coordinate that should not be the character, all of them are not the character. And made sure for every coordinate that should be matching my character, they were all matching my character. So if both of those conditions were true, I found a hugging corner, one of two walls facing me. And then came the other corners, which ruined my naming scheme. These corners, the pokey ones. So this logic is that both of these, so let me go around my scribbles, is that, so you're here, both of the ones you're facing, so remember you're facing this way, both of the ones you're facing in the horizontal and the vertical, they should be you, but the one that you're facing, whatever is here, should not be you. So it's not the same. It shares the same by getting the one to the left and the right of the diagonal you're facing, but then you also check this random one out here, the actual one you're facing. And the ones that are in the diagonal you're facing were called should not be character, so that gets really confusing until the refactor. And then the one you are facing didn't have a variable, so it was a single one lookup. The one I'm facing is not me. The ones to the left and the right of me are me. And that's a pokey corner. This is unchanged. And then the math is the math. So, I'm happy I got through that. Both the painfulness of doing it every wrong way, that like it was working, all these freaking edge cases. And yeah, if I ever did want to visualize it or do more fun stuff, probably would go down that rabbit hole again. But we're not, and it's refactoring time. And hey, maybe this advent of code or another advent of code, I will end up reusing such techniques later. But it's refactoring time. So, aside from clearing up all that trash, what we want to do is definitely go for a reusable function. We're definitely most doing that. And then I think our two switches to this is going to be, or actually, it's one switch rather. Yeah, it's how we do the thing. So I think the grouping is its own function, and then how I want to do math is completely up to me. So yeah, I'm going to do I guess I like a cool function called group the things, or I think a better name than that. What are we calling these lore wise? Garden plots. There we go. So function parse plots data string, and it's going to do all this fun stuff. We'll take this little helper up and this bit to that bit. Okay, so we have a world. Let's be lore accurate. The garden. Then we have plots. And now we have area and perimeter. Might as well go for good spelling. That's not good spelling. Perimeter. What are we calling these letters? Plant type? We'll just call this type. That's good enough. And then what we'll want to do, so we have perimeter. What are we calling the other one? Faces? This is going to calculate both. Sides. Sure, sides is good. Okay, I love it. And then let's just type this away. So type plot. Boom. So that's going to get reused a bit. Existing plot. So if there is an existing plot, so I don't need the find, I need the sum. Then it's type. Type. If it exists and I've done that, then it's good. Another thing I realize is that I don't need to count the area because the member's size will do that for me. So let's drop that. Create a new one of these. Parameter 0, sides 0, type is type. Spell things correctly, maybe. What am I missing? Oh, that type doesn't have that up there. Okay, so we'll make a group, pass it, and then we'll push it to plots. This is a weird pass by reference thing I'm doing. Can I get flood filter return stuff? So you need it for lookups. Okay, so what you really do, I mean, you add to a lot of things. Okay, fine. Pass by reference will suffice. We're good. We good. It'd be nice if you returned it though to make my signatures less ugly. Let's go for that. So that way I can do this. Ta-da! Now it's just angry because I'm not using the garden plot type. And let's rename this while we're here. Plot. Plot. You don't need to put that on areas no more. Type. And we know how to spell words. Love it. Maximum call stack. Whoops daisy. I'll look into that later. I'll look into it now. Hey, why'd you go to the Infinity Lands? If a neighbor is not equal, so what neighbor are you looking at? You're looking at undefined. It's not equal to the plot type. What? Did I do something? Oh, why is Char still here? Hey, hey, hey. This is flood fill. This is flood fill. Garden, row, column. Type. Type is the new thing. It's the new hotness. Where is Char coming from? What the heck am I looking at? Oh, code is not being ran yet. Jeez, I am. Well, get that. Why is it not working? It would help if you ran it. Okay, so let's const plots equals parse plots data. Get rid of all this old code. Now you can go through your plots. And then your properly spelled perimeter. And it's members size times properly named perimeter. And it's green again. Oh, we love it. So, big fan of this. Let's rip this out into a variable. Cardinal directions, boom. Okay, this is looking good. The ordering's a little jank, so let's fix that. Okay, better. So we could do the false exit or the true continue. So let's do every not equal. No, that makes it harder to read. I'm going from readability. If there's someone where you found it and you're already in there, get rid of you. And you know what? I don't even need to do that check. I can go straight for the membershipness. And you know what? Members, let's rename that something else. Processed. Yeah. So if there's a plot that you've processed, we'll name that to plot. Don't look at it. Got the garden, got the row column, got your thing. Love it. Since we're talking about stuff that's just getting passed, not changed, let's move that higher up. Garden never changes, so it gets first seed, but these two, the plot changes just per call, and row and column change every single day. So they get to be at the end. Makes binding easier if we want to do that. Okay, I love it. Let's make this a little cleaner. So for everything, we do that. We have our neighbor. If you're not the thing, do that, else you are. We have a key, which we use once, so let's inline it. And then let's do if you haven't been processed. Drop that. There we go. And we have an else if, so let's make it an else if. Good. Feels weird. A little better. Yeah, so if its neighbor is not the plot type, get out of here. Else it is the plot type, but is it not processed? Process. A little bit of polish could be done, but I like it. And then return the plot just for signature's sake. Okay. I am loving it. So do that, and then just add up your price. Oh, I did a naming of this, did not persist through the refactor. Boop, boop. There we go. Okay, now let's get this thing working for our part two, which I think is just adding the whole. Where'd all the. Here, all the corner counting. And handling this area a bit, which I think is just dividing it by 4 on the outside. So let's update this with corner counting. Boop, 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 boop. Type. Okay, great. And then corners, right, it's, what is it? Sides, yeah. Okay, so in theory this should work. I should just be able to throw this in place of my current flood fill. And yeah, flood fill fences, you will be missed. Did I really duplicate it twice? Jeez Louise. I was deep in the chaos. Right, so I just, instead of this, return normal flood fill. Angry about the other stuff. You know what? No, let's just go for the full plots. Cost plot goes parse garden plot data, and then let's just go over the plots, right? If it's working, it'll be working. So we have members, well, we have processed, sides, right? And then this is sides, drop that. This is process.size divide 4. ed.size divide 4 because math. Okay, maybe not divide by 4. My cornering might be wrong. Let's look, see what we're getting here. So type process size. So A has 4. Oh, right, the world is not scaled. That's the problem. So we do want to divide by 4, but we don't want you to do the world parsing. Much appreciated. We're going to do that ourselves. Yeah, we parse the world. You just sit there. Got this. Boom, love it. Which will allow us to super enhance the world right here. It's a working. Nice. And we put it on the hard stuff. Beautiful. Okay. That is the number, right? Yes. Okay. It's going good. We throw out all the old code now. Love it. Let's just squish this a little bit. I'm gonna do the other things first. Yeah, we'll polish that a little bit in a second. Taking out the trash. Drop that return. It's not that big. Okay. We are nearing the grossness. So let's see. Behind us. Forward. Behind. That's the best way I can explain it. Not the best way, but it's the most consistent naming. So let's do some booleans. So cost all behind are not part of plot. All behind are not plot. Let's say that instead. And then what's this? All in front are plot. Cost all are plot. Just to make this a little bit more readable. And then what's this one? This is not really one for it. So corner is plot, corner looking at plot. It's a really weird terminology I'm using too. I'm gonna swap this. Is looking at is not. Again, I'll change the swaps maybe later. Then behind every, so const all behind our plot. Yeah, as I write these out, it's gonna help me squash them to singles and better names. Okay, make sure all that still works. It does. Let's not put it on the hard one because I want to save my computer. It does. Okay, we love it. Now, looking at all this chaos, let's move some things around. We have the definitions and what is going on. So, CRC. I know what this means. This is like corner row offset, corner row column offset. This should be CCC, corner column. Awesome. Not awesome, offset. So behind, forward, if I'm not shoving these the same way, that's going to make it impossible to read. So we have all behind our plot and all behind our not plot. Let me make sure these are accurate. So everyone is not plot. Everyone is plot. Can I just smash these into one? It's what I want to do. And just be like, not. That still work? No, 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 it doesn't. I'm fine if we have to keep the names, honestly. It's sufficient to me. I am removing all short circuiting by doing this, which I realize, but boy, this is already tough to understand and explain. I will pay the readability price. So looking, so is member of plot. All behind are not part of plot. All behind are part of plot. All forward are part of plot. I don't know how to spell the word diagonal. I got that. There we go. And at this point, they're so abstracted as well. Now, that assumes there's never a case where both are happening at once, which, by the rules of corners, there shouldn't be, and there appears to be none. Imagine me just put it all back in. That would look horrible. Okay. And technically, we're not counting sides, we're counting corners, but it results in sides. But it's a lie, so let's change to corners. Forward, and these are cardinal diagonals. And by cardinal diagonals, I meant diagonal directions, of course. Why are you angry? Cannot redeclare. There's not. Shut up, TypeScript. Fix my project later. And I don't need these fancy named anymore because I was embedded in a thing. Like I was in a loop I shouldn't have been. That's why they were named so uglily. Now they're not. And here we are. Okay. And instead of member of, I'm going to go part of. That's what I did for all these. Okay. I'm liking that. I'm liking this. I'm liking this. Solve one, pass it, do math. Solve two. Maybe I can squeeze in some betterness here. So if I map each row to a new row, and then the next one I flat map it directly here. So this will be rows. Well, this will be row actually. And then I just do like that. Okay, row. flat map. I'm making a copy because I need a string, right? Or I need an array rather, and I have a string. I think I want to call these corners. This is it. This is my refactor. Let's do the final walkthrough and then we will call it. Okay. So, they all start with parse plots. They start by passing it the two-dimensional world that is to be processed. And all of them, we get rid of the weird return carriages, split by new lines, and we map each line into an array of strings. So that way we have an array of strings. For each of these, we define all the plots we're going to find. Remember when I said I wanted to make this a hash map? I don't. I was about to, and I was like, no, I've talked myself out of that twice. Third time's a charm. Yeah, for every row and every column, we're like, hey, what are you? And have we seen you before? If we've seen you before, then we're going to ignore you. Very sorry. We're ignoring you. If we haven't seen you before, then you need to go through the flood fill. We're going to pass you the garden. We're going to pass you your new definition of the plot, which you don't have a perimeter, you don't have corners, and you've only processed yourself, which you don't need to do because that happens inside here. So we're going to pass you an empty set so you can process yourself and where you're starting, row and column. Then the great flood filling happens. So first we look at all the diagonals and try and count the number of corners we have. So we determine which two are behind us, which two are in front of us using the math. We make a lot of lovely named variables for what these mean. And then we count the hugging corner where you have two walls facing you, or the pokey corner where you have no walls facing you and you are facing the corner itself. So if all behind them are not part of the plot and all of the forward ones are part of the plot, that is that what? Hold on. Did I invert these? All behind are not part of plot. Every behind is not the plot you're looking for. That feels like I've inverted it, but the fact that it's working is telling me I am the one who's wrong. Yeah. I think I'm just confusing myself here, but we do a lot of .everys to check, hey, are all the ones behind are or are they not? Could have done this in a better, snazzier way for efficiency, but it works. And then based on is it enough to be a hugging corner or a poking corner, if we find either of those corners, we increase the count. This literally feels like it's backward. Because if all of the things behind me are not part of the plot, but we're saying all of the things in front of me are part of the plot, we're literally saying the opposite. I might have inverted these at some point, which would understand why it's failing. I think I literally did invert them. E. I did. Oh my goodness. It makes sense. The forward one, you do plus, you're going in the direction of the corner. Wow, no wonder this is hard to follow. So yeah, we need to rename some stuff. So all forward are Apologies for the interruption to the funness. I guess I'll keep this A, B. Okay, now we can probably read it the way it's meant to be. So if all of the ones behind you are part of your plot, and all the ones in front of you, the two in front of you, left and right, are not part of the plot, so yes, yes, no, no, you're facing a hugging corner. But if you're facing a diagonal that's not part of the plot, but all the ones forward to you are part of the plot, then you're facing a pokey corner. We did it. Which made sense why I wasn't able to try and invert a thing later. Yeah, that's how that works. Then the next bit of code is we go in all our cardinal directions, figure out the coordinates for our new neighbor. We get our new neighbor. If they're not a member of our plot, well, we're gonna like pretend we put up a fence. So it's like, oh, you're cool, you're cool, you're cool. You are not cool. I'm putting up a little fence here, a little divider. So I'm increasing my perimeter by one. Otherwise, if you are part of my plot and I haven't processed you yet, well, hey, I'm going to send off the flood fill call. That will start processing you with the new row, new column. And finally, we just return the actual plot itself for no purpose other than making it easy to call right here and immediately push to plots. That's it for both of the core solutions. All that remains is the easy work of, hey, let's take numbers and multiply them together to determine our total price. And for part two, the only slight difference on the outside here is that we double the size of our rows and columns. Like we double everything by making double the columns and double the rows. And, and therefore we divide it by 4 to get back to the real number. Yeah, that's it. I'm gonna get rid of these returns. I'll get rid of this code too, might as well. Commit it away. Took me a few rounds to figure out the right formula, as I anticipated a number of times. Over optimized, or I over engineered the heck out of this solution, but that's why you gotta the diffuse mind take over every now and then, see what's going on. A tough one, but still a pleasure as always. Until next time.